Today's episode is proudly sponsored by Radical Polymers. Nation, running a water treatment business is hard. Dealing with your suppliers shouldn't be. And when I deal with the fine folks over at Radical Polymers, I have always felt like I have had a partner. They test things in the environment that we are going to use their products. They also make sure that if I have any questions, that I get the answer that I am looking for. Mike and the fine folks over at Radical Polymers answer the phones. Folks, when was the last time you actually talked with somebody when you had a technical support question? Well, they make your issues their issues and they get right down to the problem. They offer best-in-class technologies with the first-class support that I just mentioned. Go to scalinguph2o.com/radical to find out more. Welcome to Scaling Up, the podcast where we scale up on knowledge so we don't scale up our systems. I'm Trace Blackmore. I'm hosting this podcast, and Nation, this was supposed to be our Halloween episode, and I think the topics we're going to talk about probably do have some Halloween-esque qualities to them. Last year, I did something fun. It was episode 166. I actually read Edgar Allan Poe's The Raven on the air. That was by far one of the toughest things that I have ever done on the podcast, making sure that I could do that incredible work of literature justice, making sure I got my inflections right, making sure that I increased my tone and gave some more emotion as I was reading through it. I'm sure if I did it today, I could probably improve on that. There's no probably about it. I could definitely improve on that. But I did that because it was a challenge and I wanted to challenge myself. And boy, let me tell you, I definitely did that. Well, we are up against a challenge today, and it is our raw material supply chain issue and just a general supply chain issue. So, Nation, if you do not know, let me inform you, there's a whole host of things going on right now that affect how we get our water treatment products, from raw materials actually being manufactured to getting the raw materials shipped once they're manufactured to where we need to get them to blend our products. China has cut production of phosphates by over 90%. That, of course, is not just going to affect our market, but every market around the world that uses phosphonates. Add to that, it's harder and harder and harder to get goods on time because we're having shipping issues. Ships aren't able to come in on the same time frame that they used to. It's taking longer to unpack those ships. It's taking longer to get the products off of the ships and to where we need them. And of course, we have a worker issue where we don't have all of the people working that we used to in the workforce. So add all that up, and that's a Halloween episode. So I don't think I need to do anything scary. I think we're living it right now. But I think scary is a word that is probably appropriate if we don't have proper knowledge. But if we have proper knowledge, we can make informed decisions. We may not like the decisions we have to make, but at least we know that we've got information that's backing why we're making the decisions that we are trying to make. So this is going to be a Pinks and Blues episode where I am answering your questions that you've written into me and asked, what do I do? And Nation, I received so many questions from episode 221 that was aired just 2 weeks ago, and that was that episode that we aired out of order. We normally air an episode on Friday. This one aired on a Tuesday. We wanted to get the information out as quickly as possible so you could do something with that information. Well, when I did that, the floodgates opened. We had a lot of questions around what can I be doing proactively now to make sure I can continue servicing my customers and giving them the products that allow me to do my service. So I thought instead of answering all those questions one by one, I would bring an expert onto the podcast, no stranger of the podcast, Mike Standish of Radical Polymers. I want to ask him your questions so you can hear firsthand from him what he's advising to his customers and what he's seen in the marketplace. So here is Mike Standish answering your questions. I want to introduce Mike Standish of Radical Polymers. So much going on with questions about the supply chain, getting raw materials. I wanted to bring somebody on that's what they do day after day. So Mike, thank you so much for coming on Scaling Up H2O and answering some of our audience members' questions.
Yeah, thank you, Trace. Thanks for the opportunity.
Well, let's start off with you've been on several episodes, so I think the Scaling Up Nation knows who you are. So I'm going to forego that. I'm just going to get straight into some of the listener questions. The first one I want to ask is, what are you seeing with the raw material supply chain right now?
It's pretty ugly. I mean, I started in this industry in 1986, and so 35-ish years. And number one, like I think everybody else, have never seen anything like this. So, we've seen issues periodically with polymers or molybdate or what have you, but never a situation in my career, at least, where we see everything all at once, from packaging, totes, and drums to essentially every chemical that we have. It's kind of interesting to me because I think there's, at least three components to this. One is demand. I mean, at least here in the US and North America, we see demand is up for, raw materials that are going into water treatment. But what we also see is some supply issues, which is number two. So we've seen, where the hurricane that, went through Houston area in February has really disrupted supply chain. And yeah, we're coming out of that, but those plants pretty well run to demand. And so, when they're down several weeks, it's very, very hard for those plants to get caught up. And then, of course, the thing that's really jolting people at this point is the reduction in P4, which is the starting material to make phosphonates out of China. So, there's been raw material issues, which is number two. And then, number three is all the logistics issues. There's really a severe constraint on ocean transit right now. And okay, you might say, well, I buy from a domestic supplier, but it's very, very likely that those domestic suppliers are at least getting some of their raw materials via imports from either Asia or Europe. And so I can tell you, I mean, where it used to take us, our materials are coming in from Europe. It might take 30 days from the time we place an order until we start, anticipating shipment at our door. It's now 60 or 75 days. And that's due to port congestion, container availability, and so on. So there's, it's kind of a perfect storm is the way I would, describe it at this point.
Mike, what are some of your customers, what are other companies doing to weather this storm?
I think that, and what I would say is the number one recommendation I would have is that they, any of the customers, our water treaters out there, work very, very closely with your vendors. So work with forecasting on your demands, work with those companies to kind of navigate supply and work with those companies to look at alternative chemistries. So, I think some of the bigger things that people are doing is that they're, providing better forecasts to their suppliers. They're working with the suppliers to qualify, other raw materials, reformulate to give them opportunities to, adjust in emergency situations on supply. And people are looking at new suppliers as well. The one thing that I'd say about that is that everybody's pretty much in the same boat. So it's one of those things where the marketplace doesn't necessarily have excess availability of these materials. So it's not one supplier over another.
You mentioned alternative chemistries, and that's what we're going to talk about next. You've done a lot of research to see what chemistries we can replace, specifically with phosphonates, since we're not getting phosphonates out of China anytime soon. If I or somebody in the Scaling Up Nation called you up and said, Mike, I just cannot get PBTC or HEDP? What should I do? Walk us through that.
Okay, so I think, the first thing that you have to know is how these materials function and what they do well and what they don't do well. So, in a very quick capsule, what I would say is that most of our cooling water customers, our being, the industry, are mainly using HEDP and PBTC for calcium carbonate control. So, that's number one. Number two within that is okay, what functionality do they provide? The phosphonates typically are threshold inhibitors, which is basically extending out the apparent solubility of calcium carbonate beyond its normal limits. And they do that at very low dosages, so substoichiometric dosages. That's the primary functionality of phosphonates. The tools that you have to control calcium carbonate include threshold inhibition. They also include crystal modification and they include dispersion. So, polymers are a good alternative to phosphonates. They are threshold inhibitors for calcium carbonate. They can be, particularly maleic based materials, can be exceptional crystal modifiers. And polymers are dispersants. Typically, the maleic materials are not necessarily the best dispersants, but you can work with your suppliers to find that out. So I think, if you kind of step back and look at the functional tools, you have threshold inhibition, which phosphonates are by far the best for calcium carbonate. You have crystal modification and you have dispersion. Polymers do all three. The caveat that I would tell to your listeners is that all polymers are for calcium carbonate threshold inhibition, keeping the material in solution, are going to require higher dosages than the phosphonate.
And Mike, if we do replace our phosphonates with a polymer, can we now assume that it's going to have the same threshold response, or do we now need to update our data sheets and train our people into different water requirements?
I'll go into very technical gobbledygook for a minute. But so, one way to look at the limits of these materials is by what's called calcite saturation. So, for calcium carbonate, we're going to look at the limit for calcite saturation. That's how many times solubility of untreated material, how many times over and above that you can go when you treat it. So, for HEDP, generally the rule out in the marketplace is that the limit of functionality for HEDP is about 150 times calcite saturation. And for PBTC, it's about 200 to 225 typically. Some people can stretch it out to 250 and say low temperature application. Okay. The maleic based polymers can take you out into that 200 to 250 times calcite saturation. So you can actually do better than HEDP with the maleic rich materials, polymaleic types, and approach what you would see with PBTC. In terms of the limits of use, the caveat there is going to be dosage. And what I would very much recommend is that you don't just make the substitution blindly. You really examine the waters, the limits in which you currently have with the waters that you're currently treating. Work with your supplier or with your internal team to model those waters and kind of make an educated decision of what the approach needs to be for the replacement. I wouldn't recommend just, okay, I take out HEDP and I plug in polymer. You need to not only look at the dosage, but the water chemistry and the operating conditions to assure that you understand where those limits are going to be.
Mike, if people are looking at their warehouses and they see that they have very limited phosphonates, do you recommend that they do a complete replacement, or maybe they stage down how much phosphonates they're putting in their existing blends?
Yeah, Trace, that's an excellent question. And in fact, I think 100% that's what I would look at doing is staging down or extending the level of phosphonate that you can use. There's data to support that. We have data to support that. I imagine other vendors would have data to support that. I will tell you, if you're not in a 0P application and we're in normal world where people can get all the raw materials that they need and want, My recommendation is always to pair the phosphonates and the polymers together. You get complementary performance that extends the overall range in which these products can work and provide performance. So definitely the hybrid approach where you're extending the phosphonate is a great approach until you can't do that any further.
Mike, I know everybody's product is different, but what's the lowest threshold that you would want to see in any blend if they were reducing the phosphonates and how much polymaleic that they would want to put in there? If they just wanted to do bare bones, what's the minimum threshold that they would have to have in their products?
I'm going to say a typical dosage for a stressed water, and that's where you're going to get to a calcite saturation of around 200 times, and just say rough simple index of LSI of around 2.8 to 3. If you're in that, I'm going to want to have pretty heavy dosage of the polymaleic, maybe 10 to 12 ppm active in the circulating water. Now, most people aren't always operating at the limit that I was just talking about. So, if you're in a more reasonable kind of operating range where maybe your circulating water pH is 8.5 and your LSI is 2 or below, and calcite saturation of like 150 or something in that range, you might be able to get away with a lower dosage. Maybe it's 6 to 8 ppm active. It's just a very rough rule of thumb. For our products, the way that I would prefer to engage with customers on this is like what I was saying before, is let's model the water, let's look at it and make sure we understand, where the limits are.
And Mike, you've done that for us, and it's great to know what the theoreticals are. We can have conversations and we can eliminate problems before we have to experience them.
Yeah, and I'd like to make another comment. Polymers are not the only tool that you have here. It's not the only weapon. So, you might have this, and it might be a little more complicated, but let's just take a scenario where somebody normally has, say, 3 ppm PBTC and, 5 ppm polymer in their circulating water. And now they've decided, okay, we're going to cut that back to extend out our PBTC, availability. So we're going to cut that down to 2 ppm PBTC, and we're going to keep the polymer. Maybe we'll bump that up a little bit. The other kind of tools that you have to work with here is pH control. pH control is your most powerful weapon, if you will, against calcium carbonate precipitation. So, you can look at pH control of circulating water. You can look at limiting cycles. And maybe you're normally running 5 cycles and you bump that down to 4 to take some stress off the water. That not only takes stress off the water chemistry, but it takes stress off the holding time as well. And people have to recognize that whether it's phosphonates or polymers, they don't prevent the precipitation of calcium carbonate, they delay it. So time is a big factor that people tend to forget. So if we reduce holding times a little bit, we've also taken some stress off of the polymer or the additives that are going in to control calcium carbonate.
Well, Mike, with lowering concentration ratio, we're also not allowing the product to concentrate up. So at what point do we need to be worried that we might be wasting product that we can't get back?
Yeah, I think that's a great point. I tend to be pretty conservative with, recommendations and dosages. And I would say that in general, we probably all tend to overtreat with chemicals. But, it's almost better to do that than undertreat and, have a precipitation and scaling event. So I think that's a tricky question that is probably doesn't have a real good generic answer, a broad answer in this case. I really would be an advocate where people can is to look at things on a case by case basis and kind of assess, what the pros and cons and risks and rewards are.
Yeah, no one ever said water treatment was easy.
No, it's not.
Mike, do you anticipate eventually, if things don't change, we're going to see the same issues that we're seeing with phosphonates now happen with polymers?
I don't think so, at least in the North American market. We have to realize that most all polymers that are supplied into water treatment in the North America market for scale control. So I've added about 10 qualifiers in there. But most of what we're doing here in North America is produced by Western suppliers. So we're not really seeing the issue. There's a number of domestic, manufacturers of these types of polymers. There's other Western suppliers. There are Asian suppliers of these materials too. But for now, most of the polymer that's being used in our areas from domestic sources. I don't see a big issue. We are seeing some pricing pressures on raw materials, but right now there doesn't seem to be any supply issues, and there's no kind of foreseeable event for that would cause a constraint on polymers. The constraint that we saw earlier in the year was based on the hurricane that came through Texas that affected monomer production. And I think we're more or less out of that. There's still some issues, but we're kind of more or less out of that at this point.
So many people are doing Legionella due diligent programs specifically on cooling towers, which means they're using oxidizers, most likely. Do we need to be concerned if we're changing chemistries, how the oxidizers are going to affect our products?
Yes, in general, I would certainly consult with the supplier on that for sure. What I will tell you that in general, the polymers are not very susceptible to oxidation. So, and that's a broad statement, but it's true for the types of polymers that we use in, scale control and water treatment. They're not very susceptible to oxidation in general. And in fact, some products, even some of the maleic based materials, have very exceptional stability in oxidizers because they're actually produced in a severely oxidizing environment. So, yes, ask your supplier the question, but in general, know that if you're moving from phosphonate to polymer, the answer is generally no. Now, I will say this, there's a distinction between the types of phosphonates, and this is important to your listening audience, Trace. HEDP and PBTC they don't contain nitrogen in them. There's this other class of phosphonates like ATMP, DTMPA, and so forth. They're called aminophosphonates. Someone was using HEDP, they can't get it, but all of a sudden they say, okay, I can get my hands on some ATMP, for instance, a phosphonate that contains nitrogen. You need to be very concerned about oxidant stability of the nitrogen containing phosphonates, or even some of the other phosphonates that are typically used for corrosion control that have scale control properties, like the HPA type materials, the hydroxyphosphonoacetic acid. Those types of materials are very susceptible to oxidation. So if you're switching, in that direction, functionally you can do it, but be aware.
Mike, you and I and a lot of others are trying to get this information out to as many people as we can. But I have no doubt somebody's listening today and it's the first time they've ever heard this information. What advice do you have for them?
My advice is work closely with your suppliers and your colleagues, out there, at least the independent water treatment community, a pretty tight knit group, and, talk with other water treaters out there, talk with your suppliers. I think the very good news about all this is it's not, the end of the world, all doom and gloom. It's going to require us to make adjustments, but we can still treat water effectively. I think that's the high level message on this. You're just going to have to make some adjustments. And frankly, I think there's a big opportunity in there for the independent water treatment community. And the reason for that is because we can respond, reformulate, react, communicate with our customer base much, much more, readily and quickly than, many of our larger competitors.
Mike, this is almost like deja vu. 15 years ago, weren't we talking about molybdates? We could just simply replace our terms for phosphonates. We were having molybdate issues then. Can we learn anything about how we got through that and maybe anticipate how long it will take based on the molybdate crisis?
Yeah, I think that there are a lot of learnings from that. We've become very dependent upon imports, and I think that's just the way that things are in this world at this point. I think a major difference is we probably, at least in open systems, we didn't depend on molybdates as much as we do phosphonates. we were mainly using them for tracing as opposed to, scale control and something that's super critical. But absolutely, I think we become dependent on that. That's the way the world works now. I think probably the biggest learning is always be prepared for alternatives. Again, we're in uncharted waters at this point. I don't know about, how long it's going to take to come out of this, because the molybdate issue didn't have the other entanglements that we're seeing with transportation issues that are really just as severe as the supply issues, from the countries of origin. So I think, even if phosphonates today all of a sudden were, in abundant supply, we're still going to be dealing with these logistic issues that are really creating severe delays within the supply chain.
Well, I want to thank you, Mike. Again, Mike Standish, Radical Polymers, always a wealth of knowledge. Thanks for answering some questions for us, Mike.
Yeah, thank you for the opportunity, Trace.
Nation, Mike just has a way of making things that are very complex, very simple to understand. He was one of my very first guests when I first started this podcast. He was back on episode 14. So we were still learning how to do a podcast and all the things that go with that back then on episode 14. But Mike was fantastic, and he took polymer chemistries and explain them in a way that will stick with you from now through your entire career and allow you to understand polymers so much better. So I highly recommend that you listen to episode 14 to learn more about that. I also recommend that you take the advice that Mike just gave. Reach out to your suppliers. If you are using somebody to blend your products, reach out to them. Don't assume that they know all the things that are going on. Share information with them. That way, you all can collaborate on what the best solution is for you and your company. And with that, you're making the best decisions possible. Again, as I said at the top of the show, you may not like the decisions that you have to make, but at least you've got solid information behind them. Now, if you have not listened to episode 221, I highly recommend that. We had 4 experts come on the show. And actually, this was a webinar that we were doing in conjunction with the Association of Water Technologies. This was an event that was canceled at the AWT conference just a few short weeks ago. So we went ahead and picked that up and aired that as a webinar. And then I took that webinar and I put it out on the podcast so everybody in the Scaling Up Nation would have access to that. So we had Jill Cavano of Scranton Associates join us, Mike Standish of Radical Polymers, Gary Garcia of Masters Company, and John Zabrita of Zybex. We got a lay of the land of exactly what they were seeing, and you get to hear what advice that they have and what their crystal balls are telling them that they shared with us. So again, 221, highly recommend that you listen to that episode, but don't just listen to it. Share these episodes with each other. Share them with people in your company. The more information that we can get out there to our industry, the better our industry is going to survive. And Nation, I know that there is a tendency to just think of yourself, and I can get all of this phosphonate, I can hoard it whether I need it or not. And I'm telling you, that's not how you get through something like this. I truly believe that if we work together, there is nothing that we cannot endure. And I see this each and every week with the Rising Tide Mastermind. We are all working together. We're trying to troubleshoot certain issues. And because we are working together, because we're sharing information, we don't have to do as heavy lifting because everybody lifting definitely lightens the load. So take a cue from the Rising Tide Mastermind and make sure that you are being a good neighbor to all of your water treaters. And all of us water treaters, let's make sure that we're sharing the information that we have so we can make better decisions. Nation, before we sign off, we always do something to make sure we are getting better, and that is through the help of James McDonald. So here's a new James's Challenge.
Hello, Scaling Up Nation. The next James's Challenge as we grow as an industrial water treatment professional, drop by drop, is calculate boiler efficiency. There are several efficiencies around a boiler, but today's challenge is referring to the thermal efficiency. How much of the available heat energy going into the system with the fuel is leaving the system in the form of steam or hot water? Do your calculations match what you expected? Be sure to share your experience on LinkedIn by tagging it with hashtag JC21 and hashtag ScalingUpH2O. This is James McDonald, and I look forward to hearing what you share.
Thanks, James. Nation, remember, find out information so you can make good decisions. Share that information so others can make good decisions, and then collaborate with others so we can ultimately help each other. And I promise if we do that, we are going to shave weeks, if not months, off of this issue so we can hopefully get back to normal. Happy Halloween and have a great week, folks. Nation, where do you want to go? What is the next step for you, and how are you going to get there? Those are tough questions, and they're even tougher when you're trying to answer them on your own. That's why I've created the Rising Tide Mastermind, because you don't have to be on your own anymore. We all take value in you reaching your next level to success, and we will help you get there. Go to scalinguph2o.com/mastermind to find out more.